You know that feeling, right? That incredible flash of inspiration, that sudden aha moment when a solution just clicks into place. It feels so human. But what if it's not? What if a machine, an AI, could have one too? Yeah, that feeling when you're just totally stumped on a problem, and then bam, out of nowhere, the answer just appears. It's amazing. But here's the big question we're tackling today. Is that magic moment just for us? Can a simple machine have that same kind of flash of insight? So let's dig into that. Before we can even ask if an AI can have an aha moment, we've got to be clear on what we're actually talking about. What does science say one is? Okay, so researchers looked into this, and it turns out a real aha moment isn't just, getting a little better over time. Nope, it has three very specific tells. First, it has to be sudden. We're talking an abrupt, totally unexpected jump in how well you're doing. Second, it's selective. This is interesting. It only happens for some people, not everybody. And finally, there's a delay. It always seems to come after you've been stuck for a while, just hitting your head against a wall. All right, so with those three traits in mind, some researchers set up this really cool test. They give both humans and a simple AI the exact same puzzle. The trick was there was a hidden shortcut, and the whole point was to see if the AI would show those same three signs. That sudden leap, the fact that not all AIs found it, and that period of being stuck beforehand. But to really get what happened next, we need to pop the hood and see how a neural network actually thinks. Okay, I know the term neural networks can sound kind of intimidating, right? But don't worry. The easiest way to think about it is, well, it's like a sandwich. Seriously, a sandwich. Just like you've got your bread, your fillings, your other piece of bread, a neural network has layers that process information one step at a time. So let's break down the three main parts of this neural sandwich. First up, you've got the input layer. Think of this as the front door. It's where all the raw data gets dumped. The pixels from an image, the words in a sentence, whatever. It's basically like your eyes just taking in all the light and shapes before your brain has had a chance to figure out what any of it means. Then you get to the hidden layers. Now this is where the magic happens. This is the real brains of the operation. These layers take all that raw stuff from the input and start to look for patterns, for features. It's like your brain's cortex finally getting those signals from your eyes and going, okay, that's a straight line, that's a curve, that looks fuzzy. And at the very end, we have the output layer. After all that hard work in the hidden layers, this is where the final answer pops out. It might be a label for an image or a prediction about a number. It's the network's final verdict, just like your brain looking at all the evidence and concluding, yep, that's a cat. So the data flows in just one direction, in the front door, through the middle, and out the back. They call it forward propagation. Super simple, right? Like an assembly line. But that brings up a huge question. How does this assembly line learn to get it right in the first place? Well, the secret is all in the connections between the layers. A neural network learns by constantly tweaking and adjusting the strength of those connections. And it's really fine-tuning two main things. First, you've got weights. Think of a weight as a volume knob for each connection. It tells the network how important a piece of information is. Then you've got biases. A bias is kind of like a little nudge. It helps a neuron fire even if the inputs are a bit weak, which makes the whole network way more flexible. So imagine millions of these little knobs and nudges all being adjusted at once. It's all happening inside what people call the black box, and for a long time, it's been really hard to peek inside and see what's actually going on. But what if we could? What if we could just peel back the cover and watch a network learn right in front of our eyes? Well, lucky for us, some incredible tools let us do exactly that. So check this out. This is from a tool called GANLab, and what you're seeing is pretty amazing. It's a visualization of a neural network training in real time. You can literally see the data points. You can see the network's predictions changing, and watch as it slowly but surely gets better and better at its job. It takes this super abstract idea and makes it something you can actually see and get a feel for. And it really works. Someone who used this tool for a study said it perfectly. It really helps you build intuition to see how the discriminator and generator interact. In other words, it pulls back the curtain on the black box. Okay, so now that we have a better idea of what's going on under the hood, let's get back to our puzzle. Right, the puzzle. What in the world was going on inside the AI's brain when it suddenly got the answer? What caused that aha moment? Now, your first guess might be that the scientists built some kind of complicated special insight program right into the AI, but they didn't. Not at all. The real answer is so much cooler and way more surprising. It all came down to just a few simple ingredients working together in a really clever way. So here they are, the 3 secret ingredients. First up, noise. Just a little bit of randomness thrown into the mix while it's learning. Second, gating. This is basically a switch or a gate that can crank an input's importance way up or turn it all the way down to 0. And third, something called L1 regularization. This is just a simple rule that basically tells the network, hey, be efficient. If some piece of info isn't useful, just close the gate on it. Now, when you put these 3 things together, something fascinating happens. The network starts to develop what the researchers called silent knowledge. This is information that the network has actually learned. It's right there, stored in its weights, but it's not being used. Why? Because that gating mechanism has shut the door on it, turning its volume all the way down. Okay, so here's the play-by-play. That little bit of noise lets the network slowly and quietly learn about the hidden shortcut. It's building up that silent knowledge in the background. But at the same time, the be efficient rule keeps the gate for that shortcut totally closed. So the network is stuck, ignoring what it already knows. And then something just clicks. The gate flips open, all that silent knowledge comes rushing out, and boom, the AI suddenly has a brand new, much better strategy. And that's your aha moment. And what's so wild is that this simple setup ticked all 3 boxes for a genuine aha moment. The switch flipping open, that was the sudden leap. It was selective. It only happened for some of the AIs, not all of them. And it happened after a delay, that period of being stuck. So something that looks exactly like human insight just emerged. It wasn't programmed in, it just came from gradual learning plus a few simple rules. Which leaves us with a pretty mind-bending thought, right? If an AI's aha moment can come from something as simple as noise and a few rules, unlocking knowledge it already had, what does that say about us? What are our own brilliant flashes of insight really made of? Are they something magical? Or are we just flipping a switch on silent knowledge that's been hiding in our own brains all along?